students, exercise 1.3 question 1. Make correct statements by filling in the symbol subset or not subset in the blank spaces. So we'll see over here now which is a subset of which set. Now when is a set A said to be a subset of B? Suppose you're having elements of A, suppose they are 1, 2, 3. We are defining three different sets. Suppose over here, suppose you're having here 2 and 5, and you're having C is having 1, 2, 3, 4. So now you can tell that A is the subset of C. This is a subset because you can use here one more color if you want, subset, when you are using sub. So A is the subset of C if every element of A is an element of C. See here, you can see that 1 is present in A, 1 is present in C, 2 is present in A, 2 is also present in C, 3 is present in A, 3 is also present in C. Now we can tell that B is not a subset of C because you're having here 2. Element 2 is present in both of them. Here 2 is there, here 2 is there, but 5 is there only in B, but it is not there in this. So therefore we can tell that B is not a subset of C. So therefore this is the way we define subset or not subset. So from this we'll fill in this here whatever are the blanks over here. So 2, 3, 4 we can see over here whether it is subset or not a subset. So I'm just writing in this blank over here. So you can see that 2, 3, 4, this element is in this, 3 is also in this, 4 is also in this. So therefore it is a subset. Now you are having the second one, ABC and BCD. A is present in the first one, it is not present in the second one. So therefore it is not a subset. B and C are there, but all the elements of this first set should be present in the second set. Since A is not, it's an element. Whatever are all these 1, 2, 3, these are elements of the set A. And elements can never be subset of B or A or C. But what can be, if you are taking as a set, sets only can be subsets of different sets. So therefore here you can tell that A, B, C is not a subset of B, C, D because A is not present in the second set. Now next, third one, X such that X is a student of class 11 of your school, dash X such that X is a student of your school. So now definitely you know that this class 9 student will definitely, students of class 9 will definitely be a subset of students of your school, because school under the school you have all the sections, that is from class 1 to class 12. So therefore student of class 12 will definitely be a subset of student of your school. Next, fourth one, X such that X is a circle in the plane, dash, the one set is this and the other set is X such that X is a circle in the same plane with radius 1 unit. Now in this problem what do we have is, we are having that here there is a circle where, if suppose you are taking circle in a plane, it can be of different radius. You are having here 1 unit radius, then you can have 2 units radius, you can have 0.5, you can have 2 units, you can have different circles in this plane. Now when you are taking the other plane here, this is the second plane, X such that X is a circle in the plane with radius only 1 unit. So in this circle, the second set, we are having only this one, it is having only a circle of radius 1 unit wherever it is in the plane. So therefore this will definitely not be the subset of this set, because in this you have all bigger circles also you can have. So therefore this is not a subset. So therefore next, going in the fifth one, X such that X is a triangle in a plane, and the second set consists of X such that X is a rectangle in the plane. Now in this set you are having only triangles. Only triangles are there in this plane. Okay, only triangles are there in this plane. But in this plane you are having all rectangles. So therefore this will definitely not be, a triangle cannot be rectangle, therefore it is not a subset. So therefore this is also, the fifth one is not a subset of the second set. So X is a triangle in a plane is not a subset of X is a triangle in the rectangle in the plane. Next, sixth one, X such that X is an equilateral triangle in a plane, and dash X such that X is a triangle in the same plane. Now you have triangles of different shapes. If you are taking this this screen itself over here, whichever we are having, suppose we take all triangles, we can take all equilateral triangles in the first set. They're all equilateral triangles of different types. So we're having all is a triangle in the same plane. So in this you can have an equilateral triangle, you can have an non-isosceles triangle, you can have a scalene triangle, you can have different types of triangles here. In this only equilateral triangle, small, big, and every type of triangles. In this you can have all different scalene, you can have isosceles, all right angle triangles. So you can have this in the second set. So therefore equilateral triangle is definitely a subset, because this set consists of all types of triangles: equilateral, scalene, right angle, obtuse, right obtuse, all sorts of triangles in this only equilateral. So therefore definitely here you will have this as the subset of this second one. Next, seventh one, x such that x is an even natural number dash x such that x is an integer. So now what are all the natural even natural numbers? We'll see even natural numbers will start from 2, 4, 6, so on. All these are even natural numbers. You know that integers, what does integer consist of? You know that integers have all in -3, -2, then -1, 0, 1, 2, 3, 4, 5, 6, so on up till infinity. So therefore definitely you can see that this element over here is an element of this, 4 is an element of this, 6 is an element of this, and 6 is an element of the second set. So therefore the first set, that is x is an even natural number, is definitely a subset of x is an integer. Next we'll go to the next problem. So now going into the second one. In the second one, examine whether the following statements are true or false. First one, AB is not a subset of BCA. BCA. Now, what is the difference between subset and belong to? I'll just tell you all. See over here, you're having these elements. Now this, whenever you're writing, these are all elements. A, B, C are elements of any set, right? If you're writing within the braces, this becomes a set. So this will definitely be a subset of a set which consists of these two elements, isn't it? A, B is in the set. So therefore it is a subset. But what is given in the first statement here, it's given not a subset. So therefore this is a false statement, isn't it? So it is a subset. Now what is the difference between set and what is the difference between element belonging to a set? We'll just see. Now here A belongs to the set ABC, okay, and this does not belong to ABC because it is not an element with the braces. Suppose if it was given as A, B, C, so this within braces, then you can tell that this is a correct statement. That means this we can tell that A belongs to, you can tell here in this case that A belongs to ABC. But if it is not there in this, if suppose here you are not having this braces, you are having only A, and if you write like this, A belongs to ABC, then this becomes a false statement. It becomes a false statement because elements only belongs to a set, but a set cannot belong to a set, isn't it? So this set cannot belong to the set, but only elements can belongs to this set. So therefore this is a false statement. A will belong to ABC. This is a true statement. Okay. So now taking this into consideration, we'll start doing this exercise. So the first problem we finished. We told that it is a false statement. Now the second one, look into the second one. You're having A is subset of set of all x such that x is a vowel in the English alphabet. Now over here you're having what are all the vowels in English alphabet? A, E, I, O, U, isn't it? These are all the vowels in English alphabet. And now what is given, that A is the subset of the set. So now whenever you are writing within braces, you tell it is a set. So set can be a subset of anything, but element cannot be a subset of anything. So therefore here A is a subset of this is a true statement. This is true. Got it? Now next one, you can see this clearly. This is a false statement because one is in the set but one is not in the set. I'm sorry, one is also there in the set. 2 is there in the set but 2 is not there in the set. It's not there here. 2 is not there here but it's there here. and here that means here this element is not there in this both of them, it's not present here. 3 is present in both of them, so you're having 3 present in both of them, but 5 is, so therefore it is not a subset. Therefore they wrote that 1 2 3 is a subset of 1 3 5, therefore it is a false statement. So you can write it as a false statement. Got it? Now next, fourth one. Now here you have written in braces, set A is the subset of ABC. So is this true? Yes, this is true, because if you are taking this as a set, then you can tell that ABC, A is a subset of ABC. But you cannot tell that the set A will belong to ABC. Okay, you can tell that A will belong to ABC, but when you are writing within braces, then you cannot tell that this does not belong to the set, because when it is belonging, when does this set belong to the set? It belongs when A in braces is written here and you're having this. So then you can tell that this is there in this is also a set, then you can tell that this element belongs to the set. But when it is in this way, you cannot tell that this belongs to this. So therefore you can see the fourth one is a true statement, it is a subset. A fifth one, you cannot tell that this is belongs to this, you can tell that an element will belong to that. You can tell here that A will belong to A, B, C, then this is a correct statement. This is also a correct statement, but you cannot tell that this is not a correct, because A does not belongs to A, B, C. It's not an element. If it is there in this way, then it's an element. Therefore, this is a false statement. You got a false statement here. Okay. Next, going into the sixth one, x such that x is an even natural number less than 6. Is it a subset of x such that x is a natural number which divides 36? So what are all the even natural numbers less than 6? We know that they are 2, 4. They are even natural numbers less than 6. So we'll see what are all the natural numbers which divides 36. So all the natural numbers which divides 36 are 1, 2 is also dividing, 3 is also dividing, 4 is also dividing, 9, then you're having 12, then 18, then 36. So now from this you can definitely see that here 2 4 is definitely a subset, because this 2 is here, 2 is here, 4 is here, 4 is here. So it is a subset of this. Therefore it is a subset of all natural numbers which divides 36. Even natural number less than 6 is a subset of a natural number which divides 36. So therefore this is a true statement. So now here these are all the true. There are 3 trues and 3 false. This is about the second one. We'll go into the next. Yeah, looking at the third question, here given that A is equal to 1, 2, 3, 4 within braces, 5. Which of the following statements are incorrect and why? Now before going into the problems, just let me tell you what is the difference between subset and when an element belongs to an set. Okay, so now here you can write that 1 belongs to set A, 2 belongs to set A, 3 4 when it is in braces it belongs, because these are all nothing but elements which are you are having, that is 1, 2, 3 4 within braces. This is one single element over here, and then 5 also belongs to A. You can also write, if this set, suppose you are writing here inside this set there is one more set in this way, such that you are having, if suppose in this braces 1 2 5 is written, then you are having here 3 4, and if you define the set as suppose B, then you can tell that 1 2 5 belongs to B, because this is written in separate braces over here. So therefore when you are taking the set also in one more set, then you can tell it is belonging to. But if you don't tell that within braces, if it is not written, you cannot tell it is belong. 3 4 is given in the first problem over here. 3 4 is a subset of A. Now 3 4 is nothing but an element of A. It is not a subset. If you are writing here 3 4 within this braces like this, then you could have tell that it is a subset of A. This is a correct statement. But this which you are having is a false statement. This is false or incorrect. Okay. Now 3 4, is it an element of this? So you can see from here 3 4 belongs to A. It is true. Next, The third one you're having 3 4 is the subset. Just now we have seen that this is a true statement, isn't it? Because 3 4 is an element under braces. If you're putting it within braces, it becomes a set. So therefore this is a subset. So therefore this is a true statement. Next, 1 belongs to A. Yeah, definitely 1 will belong to A because it is an element of A. So 1 will belong to A is true. Now 1 is a subset of A is false. Why? Because here you have to write that 1 is the subset of A, means you have to write it in this way. Next, 1 to 5 is the subset of A. Is it true? Yes, definitely this is true because these are all they form the set A. They are in the set A, so therefore this set will definitely become one more set, which is a subset of A. 1 to 5 can become one more set, which is a subset of A. Next, 1 to 5 belongs to A. Now you are given that in this statement 5 is there. Here, if suppose this statement was written in this way, that is you are having 1 to 5 in this way, and then you are having 3 comma 4 comma 5 in this way, then you can tell that this belongs to, that means you can tell from this that 1 to 5 will belong to this given sets, this set. That is, if you name this as B or something, it will belong to the set. But here in this you are having 1 comma 2 comma 5 are all elements. Okay, so this is this set within, if it is given within one more braces, then this will never belongs to A. So therefore this is a element present in A. Then only you can tell that 1 to 5 will belong to A, like this, as an element. Therefore this is a false statement. Next, 1 to 3 is a subset of A. This is also false because 3 is not there in this. It is separately written in this way. 3 4, it is an element. This 3 4 is an element, so this will not be a subset of A. This is false. Next, 5 belongs to A. Now when belongs means it should be an element of A, isn't it? So 5 is not an element of A, therefore this is false. But 5, is it a subset of A? 5 belongs to A. This is a false statement because 5 is not an element of 5 is not an element of A. So therefore we can tell that this 5 belongs to A is a false statement. Now next, 5 is a subset of A. Yes, this is true because empty set is the subset of any set. Empty set or null set is the subset of any set. Is the subset of any set. Now next, 5 is a set. You are taking this as a set is a subset of A. This is a false statement because you cannot write 5 within the braces. Empty set is an empty set, you write it as 5. But if you are writing within the braces, it should become an element of that set. Then only, if suppose this statement will become true only when, if suppose A is having this element in this way. If it is having this element in this way, then you could have told that 5 within this braces would be a subset of A. Then this would be a true statement. But because this is not there, it is not in this, 5 is not present in our original A. So therefore this is a false statement. So these are all the trues and false over here. So you can see false, this is false. Here you are having this false, 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 false. The remaining all are true over there. So the true ones also, I'll just put it in blue so that you will be able to notice it easily. Okay, this is the third problem. Now we'll go into the fourth problem. Now going into the fourth problem. Now here in this problem we have write down all the subsets of the following sets. So now here what are all these power sets also we can see here. So now here if you're telling subsets means you know that what are subsets of a given set, right? The set of all subsets is called as a power set. So if number of elements of set A, suppose you are taking here one set A, let that set be equal to suppose 1 2 3. Now number of elements in the set A are how many? 1 2 3. So number of elements in the power set of A will contain 2 to the power of Suppose if it contains 3 elements, so 2 to the power of 3. That means if n of a is equal to m, then the number of elements of the power set of a will contain 2 to the power of m. So this is the formula which you have to remember here. So the number of elements in the power set is nothing but the set of all subsets. So remembering this concept, we'll be doing what is this, what are the number of subsets of this, so that you can understand it more easily. So write down all the subsets of the following sets. So subsets, here you can take the subsets of the given set. Suppose you name this as A. So subsets of A is equal to, what all you'll have empty set is always the subset, and then A. These two are nothing but the subset of this. Next, now if you want to know what is the number of elements, now what is the subset of this, means how many elements are there in the set A? Number of elements in set A are 1, isn't it over here? So n of A is equal to 1. So power set of this n of A will be equal to power set of this A will be equal to nothing but it's written in this number of elements of this P of A, it is written as power set. This is called as the power set. Power set is nothing but the set of all subsets. So you can write that here P of A is equal to, here I am writing here, I'll write it in blue color. Okay. So P of A is nothing but equal to set of all 5 comma A. This is said to be the power set. So how many elements are there in this? 2. But the number of elements in A is 1. So how did we get the number of elements in this? You know that the formula I told you here, n of A is equal to m, means n of the power set of A is equal to 2 to the power of m. So 2 to the power of 1, which is equal to 2. So you are getting here 2 elements, isn't it? So therefore that is the power set. Next, going to the next one. What is the second one? You are given that AB. So subsets of, you take this as B. So subsets of B is equal to 5, you can take first, then it will be, we can write it as A, then you can write B separately, then you can write AB. So these are all the subsets of the set B. So now what is the number of power set of this? Power set of B is nothing but, you can write it in this way, that is power set of B is nothing but it is equal to, you have to put your braces like this, 5 comma A comma B comma AB in braces. So now you put this, close this braces. So these are all the elements of power set of A. So therefore here you are having how many elements? If you are having here 2 elements in B, what are the number of elements in the power set? It is nothing but 2 to the power of 2. So that is 4 elements. So you can see here very clearly 1, 2, 3, 4 are there in your power set of B. Now going into the third problem here. What is the third problem here? Here 1, 2, 3 is given. So what are all the subsets of this? We'll see. Subsets of, you name the set as C. So subsets of C is equal to 5, 1, 2, 3, then you can write it as 1, 2, 1, 3, then 2, 3, then you can write one more as 1, 2, 3. So now totally how many you got? 1, 2, 3, 4, 5, 6, 7, 8 you got. So therefore our power set consists of, you can write it here only, we'll write down here, power set of the C consists of 8 elements, because you can see that n of, from this you can write n of P of C is equal to 2 to the power of 3, which is equal to 8, because you can see here there are 3 elements. So 2 to the power of 3, which is 8. So what are all those elements? You have to put just a brackets for this, that's all. Pi 1, 2, 3, 1, 2, 1, 3, 2, 3, then 1, 2, 3. Okay, so therefore this is the power set of C. Now going into the last one, phi. You know that subsets of this, phi is a subset of itself. So therefore here you are having only one subset. If you take this as D, subset of D is, we are writing in red, isn't it? So if this is equal to D, so subset of D is equal to phi itself. So number of elements in the power set of D is equal to 2 to the power of, because phi doesn't have any element, so it is 2 to the power of 0. The power set consists of only 1, that is nothing but it is equal to phi. Phi within braces we are writing. Got it? So now we'll go into the next question. We have seen here even what is the power set also. Next question is also about that. Now in this question what is given is how many elements has P of A if A is equal to phi. So now here A is equal to phi means, what does this mean? A consists of how many elements? It is empty. Since it is empty, so number of elements of A is equal to 0, isn't it? Now what is this power set? How many elements will the power set of A consist? Now you know that n of A will consist of m elements, means the power set will consist of 2 to the power of m elements, isn't it? So therefore here you are having that n of power set of A will consist of 2 to the power of 0, which is equal to 1. So how many elements has power set of A is nothing but 1, because here P of A is nothing but it is equal to phi. You write it in braces. So therefore this will consist of only one element, that is the phi, that is empty set. Got it? So therefore the answer is 1. How many elements has P of A is 1. Next problem. We'll go into the next problem, that is sixth one. Going into the sixth one, write the following as intervals. Write the following as intervals. So when we are writing this as intervals, we are seeing that this is given in set builder form, x such that x belongs to R and x lies between -4, which is not including -4 but it is including 6. It's less than or equal to 6. So now when you are representing it on the number line over here, you are having a number line here. When you're taking a number line in this way, see on the number line, if suppose here -4 is there, then you get here -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. So now when we are representing these numbers on this number line, here what all numbers we are taking here, it is x is lying between -4, but it is not including -4. So we'll put the circle over here. Now all these numbers which it is including still here, all this dark line which I am taking in red, it's including, and it's including even 6 also over here. So here how do we write this type of interval? It is not including -5 but it's taking all these infinite values between -4 and 6. That is, these are all the infinite number of values between this. So you can write this as open near -4 and closed near 6. That means it's including 6 over here. So therefore there are infinitely many real numbers between -4 and the 6. On the real number, on this number system number line, I have put only integer values, but between -4 -3 there are infinitely number of values. So between -4 and 6 you are having infinitely many values. So we are writing only that interval which includes this, that is -4 it is not including, that's why we put this type. We are writing it is in this way, this circle which is having a hole in it, and here this is a dark one. So therefore this it is -4 comma 6, open towards -4 and close towards 6. So this is called as open interval. This is open interval and this is closed interval. I have already explained this in my introduction video for the concepts, basics, sets, basics. You can see into that video. I'll put it in the description. You can see about all the concepts. Now next, second one. What is the interval we write over here? We can write -2. It is open here. It is not including 12. -12 also it's not including. So we write it as an open interval. Next, in this case, third one, it is including 0. It is excluding 7. So we write and open the side and close the side. Next, last, fourth one, it is x is including 3 and it's also including 4. So we write a closed interval 3 comma 4. Next, we'll go into the next problem, the seventh one. So write the following intervals in set builder form. Now just now we wrote a set from set builder form to open and closed interval forms. Now we are writing from this interval form into set builder form. So what is this equal to? We'll just write down. What is the first set equal to? We'll say you're getting this is equal to set of all x such that x belongs to real numbers and x lies between, because both are open, so you can tell that it is equal -3 and 0. You're not having a less than or equal to sign for this. So it's x lies between -3 and 0, excluding both those numbers. We are not including them because it's an open interval. Next, in this, what you can write this in set builder form, because it's closed both the sides. You can tell x such that x belongs to R, and here x lies between 6 and 12. It is also including 6 and 12. So 6 is less than or equal to x is less than or equal to 12. We write down. Now next, the third one. You can see that here you can write it as x such that x belongs to R. X, here you are having an open interval towards 6 and a closed interval towards 12. So we can write this in this way. X lies between 6 and 12, not including 6 but including 12. Next, the last fourth one in the seventh problem, you can tell that x such that x belongs to R. X lies between the interval -23 and 5. Here it is including -23 but it is excluding 5. So this is the way we write about closed and open intervals as from into set builder form from interval form. Next, we'll go into the eighth problem. What universal sets would you propose for each of the following? Now the given sets are set of all right angles. The universal set for this will be universal set will be all set of all triangles or set of all polygons. Next, in this also you can write that universal set is set of all triangles or set of all polygons. In this set, again going into the ninth problem, given the sets A is equal to 1, 3, 5, B is equal to 2, 4, 6 and C is equal to 0, 2, 4, 6, 8, which of the following may be considered as universal sets for all the three sets ABC? So now A should be also contained in this universal set, B should also be considered contained in this universal set, C set should also be considered contained in this universal set U. So now here what all sets we are having ABC, all these elements should be in this universal set. Basically it's that. So this universal set should consist of all these elements of A, B and C. Then it is said to be a universal set. So now here you can see that A, you see, if you take this set as, suppose you take this as, if you're taking this as E, so is A a subset of this? Yes, A is there in E, is a subset of E. Then because 1, 3, 5 is in both of them, 1, 3, 5 is here, 1, 3, 5 is also here. Next, B will see. Is 2 4 6 in this? Yeah, 2 4 6 is here also, 2 4 6 is also here. So therefore we can tell B is also a subset of E. Next, C, 0 is there, 0 is here also, then 2 is also here, then you're having 4, then you're having 6, but you don't have 8. So therefore C is not a subset of E. So therefore this is not the universal set. You cannot consider this as the universal set. Now next we go into 5. 5 is, there's only one element, so this 5 does not have any element, so it is not at all a universal set. You cannot take here anything. So next, going into the next one, the third one, we will see that whether this is a universal set or not. So now here you're having 1 3 5. So here you're having 1 3 5 in this, 1 3 5 is also here also 1 3 5 is there. So therefore A is, if you take this as suppose universal set, we'll write this as universal set. So A is a subset of this universal set. Next, if you take B, 2 4 6, is it also there? Yeah, 2 4 6 is also there in this. So therefore B is the subset of this universal set. Next, C, 0 0 is here, 2 is also here, 4 is also here, 6 is also there, 8 is also there. It's having more elements than that also. So therefore C is a subset of U. So you can take that this, which universal set is nothing but it consists of 0 1 2 3 4 5 6 7 8 9 and 10. So this is said to be a universal set. Now fourth one we'll just see here, because 0 is not there in this set, so therefore this cannot be the universal set. So you cannot consider this. So you cannot consider these, only this is the universal set. So that's about this. Basically you can go into the basics of sets. I'll give in the description box the link where you have all the basics, and exercise 1.1 and 1.2 is also done. I'll give the link over there so that you can go and follow up over there. Thank you.